Looking at Saturn through a standard optical telescope reveals a serene, butterscotch-colored sphere. Compared to Jupiter, with its violently swirling red eye and turbulent bands, Saturn appears remarkably calm. This smooth, uniform exterior often leads observers to assume the atmosphere is passive, lacking the thermal energy required to drive complex weather systems. The North Pole suggests a different reality. There, a rigid, six-sided jet stream spins continuously, defying the standard curves of planetary weather. Each side of this hexagon is wider than the entire Earth, locked in this exact configuration for over 30 years of continuous observation. Gases in a vacuum do not naturally form sharp angles. Saturn's optical uniformity serves as a mask for highly structured, powerful atmospheric anomalies. This calm facade periodically breaks. Roughly every 20 to 30 years, massive, intensely bright eruptions known as great white spots burst into the upper atmosphere. These localized storms grow with enough speed to wrap completely around Saturn's circumference within weeks. The existence of these planet-wrapping storms and perfectly geometric polar jets suggests a hidden mechanism beneath the visible clouds. Probing this mechanism requires moving past the visible light reflecting off the surface and descending vertically into the lightless depths of the planet. Understanding these systems requires analyzing Saturn as a three-dimensional, deep ocean environment, where surface features are only the topmost layer. At the visible cloud deck, the physical mechanics of the hexagon become clear. The structure relies on anticyclonic shielding. A ring of counter-rotating winds surrounds a central storm, pinching the jet stream into a polygon. Maintaining those sharp edges requires a steep latitudinal gradient in wind speeds. These wind cylinders must plunge hundreds of kilometers deep. This geometric crust marks the top of a highly structured fluid dynamics engine rooted deep within the atmosphere. Descending 50 to 250 kilometers below the tropopause leads to the weather layer. This is the origin point of the 2010 Great White Spot. In this dark region, condensing water and ammonia ice mix to fuel a massive convective engine. This chart compares Saturn's baseline thermal radiation to the storm's output. The 2010 convection released 10 to the 17th power watts of energy, a significant fraction of the entire planet's total radiated power. This thermal engine produces localized lightning outbursts alongside violent upward drafts that penetrate the atmosphere above. That upward thermal punch warms the stratosphere by 80 Kelvin and shifts the balance of hydrocarbon chemistry, spiking levels of ethylene far above the storm site. The localized white smudge visible in our telescopes represents the surface exhaust for a vertical thermal engine that reconfigures the planet's chemical composition through convective force. Another 100 to 200 kilometers deeper, the atmospheric pressure is intense and the environment is completely opaque to visible light. Mapping this layer requires radio wavelengths, captured by observatories like the Very Large Array. Radio scans reveal lingering disruptions in ammonia gas concentrations located exactly beneath the sites of historic megastorms. These storms transported ammonia downward through heavy precipitation. In this dense environment, it takes centuries for material to re-evaporate and cycle back towards the surface. These deep ammonia scars prove that a megastorm's impact on the planet's structure lasts for hundreds of years after the visible clouds have vanished. Returning to the optical view, Saturn appears once again as a calm, uniform sphere. We now know those visible cloud tops are the temporary exhaust of massive, centuries-long convective engines operating in the deep. Transitioning from optical to radio data reveals a patchwork of chemical ghosts. These dark anomalies are the markers of violent events that occurred decades ago. Saturn's atmosphere functions as a memory bank, hoarding the chemical fallout of its most violent outbursts within its lightless layers. The face of a gas giant is a composite of centuries of atmospheric violence, recorded sequentially through every layer of the gas.